All right, today what we're going to be talking about is Boyles Law. And what variables does Boyles Law with? Well, what it does is it deals with pressure and volume. So because it deals with pressure and volume, what it means is that all other variables that change gases will be the same. So the amount of gas you have, so N, and also your temperature of a gas. Okay, how do I remember Boyles Law is with V and P? Okay. Well, this goes back to a while, and it's going to be hard. You guys should Google her. But her name was Susan Boyle, and she was on America, or not America's Got Talent, but Britain's Got Talent. And they were very surprised, let's say, at how the voice that came out of this woman's body, I guess you want to look at it as. So I would go on Britain's Got Talent and look up Susan Boyle. Okay. And what she was, she got second place in Britain's Got Talent. It was this huge deal a few years back. And what was she then? She was the VP. Okay, so she was the VP, so she was like the runner-up, the vice president kind of a thing of Britain's Got Talent. But seriously, go look up a video of hers. It was she's a wonderful singer. But anyways, what Boyle's Law states is that if you increase your pressure, then your volume goes down. Typically, what we'll change is we'll change the volume, and because we change the volume, the pressure will change. Okay, so the formula for that is P1 V1 equals P2 V2. It is an inverse relationship, as you can see with the graph. Okay, so what is that? What are some real life examples? Well, if we change the pressure in a syringe, what we're doing is when we're changing the syringe, like let's say pushing it down, we are decreasing the volume. So what happens is you push down a syringe when you're decreasing the volume, you can feel the pressure increases. So that would be an inverse. Now, the second one, an increase of the size of bubbles as they rise to the surface of water, that's the opposite. That's nature taking care of the pressure. So as you go up to the surface, your pressure decreases. Okay, that's why your ears feel that pressure when you're going underwater, because there's more and more pressure on you. So when you're rising to the surface, your pressure decreases. What happens to the size of a bubble? Well, bubbles are made out of a gas, and what happens is actually the bubbles go up, so your volume of your bubble increases. So typically when we're doing stuff, we are changing our volume, but in nature sometimes they'll change the pressure, and then because of that the volume will change. So let's just do a real life example. 2 liters of a gas at 740 millimeters mercury. What is its pressure? What is its volume at standard pressure? Okay, so this of means possession, so those two things will go together. So I am going to label this guy as P1 and this guy as V1, which means this will be my P2 and this will be my V2. So my formula is P1 V1 equals P2 V2. So my P1 is 740. Notice that it doesn't need to be in any particular pressure unit. It just needs to be in a pressure unit, and they need to be the same on both sides. Same with your volume, so times 2.00 liters. That equals standard pressure. Standard pressure, remember, is 1 atmosphere, 760 millimeters mercury, 101.3 kPa, so on and so forth, which you'll be given on your conversions chart, but you have to understand that that's standard pressure. So because I'm in millimeters of mercury on the left side, I'm going to be millimeters of mercury on the right side, which is 760 millimeters of mercury. Okay, and that is times my variable of V2. So when you solve for volume, you get volume equals 1.947 liters. So when you round to sig figs, you get 1.95 liters. All right, hopefully you kind of understand. We'll obviously be practicing a lot more problems, but Boyle's Law is remember, Susan Boyle was the VP of singing, so that's volume and pressure, and then it is an inverse relationship, so as one goes up, the other goes down.